So, as nicely introduced, I'm here to talk about messy data, or rather about not so messy data. So first, so you're not confused, here's a picture of me with a dragon. I work at Liip. It's a digital web agency in Switzerland. But since 2022, I work remotely, close to home, which is a little bit south of here, close to Gothenburg. I'm sure some of you heard of it. And I'm a developer and architect. I've been coding since I was smaller than I am now, a kid. I started in Perl, writing those cool IRC scripts. So, the problem. We started, as many of you, a tiny API for a website. So, you don't really think so much about the architecture when it's just a tiny API to output some things on a single website. Pretty simple problem that most of us had. But as this huge retailer in Switzerland, it's actually pretty nice to have an API for these sort of things. Why don't we let them do all of our data? So then they started throwing data sources on us, all kinds of legacy data sources. And because it was in Switzerland, they also had some sort of funky thing with weird mixture of languages and units. And it was data not really meant for our age, but rather for print. So we had a challenge to output something beautiful that people and apps wanted to use. Our technology stack organically grew, but I'm not here to talk about the technology stack. I'm here to talk about the API itself. So this is a very, very simplified view of our API. So we have the data provider. It started as just one, but then it grew and grew and grew, so we had a lot of data providers. And then we started with the importing. And the important part of importing data is that you always have to import the original data. So if you don't save the original data, what are you going to do if there's a bug? You have to go back, ask your providers. It's not sure they still have the data. So always think of a way to save the original data. So then we're mapping the data, making something beautiful out of the mess into a document store. And in this document store, we have each final language. Great. And then we actually build an API on top of that. But the beautiful part of that is that your data and your API is very separate. And have you ever read an article somewhere with a catchy title such as APIs on speed or API responsive faster than Sonic? It's usually cache these days. That's sort of how you cure the slow APIs. And the challenge with cache is being clear on when to clear it, pun intended. As they say, the two hardest things in software engineering is naming things, cache invalidation, and off-by-one errors. But use cache and it will help you so much. And when the data providers are slow, instead of requesting data from them, have them give you their data, because that helps a lot. There's different ways in doing this, and every different provider has sort of difficult time using your queues to just push them there. But even if they just put it in an FTP folder and you have to read that data, I feel like it's still nicer. And most will know how to use webhooks these days. And how much stuff can you put in a JSON file, right? When you consume a lot and a lot and a lot of data, you also have to find a way to output that data. We found that using edge sites includes really, really works well. So edge sites includes are like cache that breaks a big meal into bite-sized little pieces, little snacks, if you will. So you can cache and serve individual parts so that the end user gets the important parts first, and then slowly get the rest of the response. Obviously, ideally, you should break it up, but that's not always possible. So how do you then tame the unreliable APIs? We all think that an API is going to be up forever, right? Including our own APIs. But instead, we do retry queues. So we retry and retry and retry. It's not an if it happens problem, it's a when it happens. So if we build a queue-based architecture, it's just going to work magically. And messy data, call a DataMapper. This is sort of the heart of a challenge. How would we take an API that started at something really, really tiny and kept evolving it for a decade and still like working on it? Part of it is our DataMapper pattern. Because one of the main problems in retailer data is units. So you think you can just install a library, a framework, something to solve this unit conversion for you. And that's really great, you know, from grams to stone or whatever you have. But what if you then have some weird abbreviation in French? So you have to sort of make your own unit mapper in between. So you have your original messy data, you put it in a mapper, and you output something beautiful. You could think that's pretty simple, just putting things in there. And then you put more and more and more and more things into the mapper until, kaboom! It explodes because you have to map all the things in one single thing. That's not ideal. So then you have to start breaking it up a little bit. You take a mapper interface. So you map the description separately, the name separately, and the image separately, which is a great idea. But then you have mappers that depend on each other, right? So the short description might depend on long description, and then you have this config, where you have mapper 1, mapper 2, mapper 3, run through this order. That turns out to break our API a lot. One of us devs just accidentally changed the order and suddenly the data is wrong. So one of our learnings is never have a config list of any kind. Always have it in the mapper itself. Always let the mapper list dependencies. So in Symfony that we're using, we have the compiler pass to just make sure the mappers know in which order they're gonna run. But then, because it's Switzerland, we get into the language problem, right? And how do you map everything in every language? You want an output in every language. So we look through all the mappers 3 times. That's not very ideal, is it? So then we added, is this mapper language dependent? Yes or no? And that worked really well. It saved us 60% of the data. Another interesting thing is, before we even get to the mapper stage, do we actually validate the data that we have? So instead of mapping, we can validate with JSON schema and tell the provider, hey, your data, it's wrong. We can't map this. it doesn't even have this weird French unit. So JSON schema is pretty nice to use, especially when they have this weird mixture of languages, as you can see here. It's a little bit messy, but we'll tell them, hey, we expect the mass. If you don't give us the mass, you're doing it wrong. And another important lesson we learned is that incomplete data is usually more better than wrong data. So it's easy in a mapper to be a little bit optimistic about what you can do, how you can fix the data. But if you don't know, don't do it. In our API, we also had serializing and versioning. That's how we dealt with versioning over the years. So we had one data source in Elasticsearch, but to change everything, we had virtual properties with the serializer rather than having a data source for every version and the data growing. So that was quite important for us. Then there's the clean code, clean API things. A lot of people think about test and logging and monitoring, but it's really, really, really important. I recently worked for a project where we were having the logs on the server. So every time I wanted to check something, I had to SSH in, I had to check the logs, and it was hell. So a searchable logging system is a must-have for an API to survive this long. And monitoring the data queues, sometimes we forgot to check how big the queues were. So make sure that you have alerts that alert you in an appropriate place. Another thing was that suddenly we could get a call. Hey, this discount endpoint has no data. What's going on? So be ahead of your customer and have acceptance tests to check, okay, does this endpoint have the data it has? And check as often as you need to. Make sure your logic is solid and you don't introduce bugs with changes. And one of the things us developers like to forget is that the soft skill of the project is just as important as the tech. Because even though we have a really good technical solution, how are we going to run this project for so long with the team, and how is everyone going to be on board for 10 years? Communication is hard. We have to work together, so we have to practice on graceful feedback and giving each other good feedback and accepting the feedback that is given. Team events is a way to keep morale high. Sort of difficult to do remotely, but I find a remote coffee just to sort of chat about things. Obviously, I don't drink coffee, but it works. And here's the tricky part. The customer really has to believe in code quality for us all to enjoy working on this. Because if the customer doesn't believe in code quality, they're not going to pay for code quality. So for some customers, you can try to sort of guerrilla refactor. So in every change you do, you can refactor a little bit and make the code a little bit better as you go. But for this project, the customer truly believed in code quality, and that made it a joy to work with. So when evolving your API, prioritize upgrades. Upgrade as soon as possible, because you have all those tests, right? So you can run on the latest technology. It also means you get all those security fixes, you get all of the performance increases. Upgrading means, obviously, don't upgrade to beta versions, to stable versions, but upgrade. And here's one that I think a lot of us don't get to do enough. Refactor often. Keep code smells and technical debt to a minimum. And how do you get to refactor when the customer thinks, hey, refactoring is not in the budget? You try to build a culture where that's part of what you do. And code reviews. Respectfully improve your code together. As developers, we like to sort of point out what's wrong in the code reviews. But I like to also point out what I like. That built a team that keeps the good habits and has a really good code confidence. Use defensive programming. This should never happen. It will. So everything you can think of, make sure you test for that. Make sure you validate that, because something weird is going to happen. And suddenly an endpoint is going to be in the wrong language. So also, if you can, I believe if we make money on our APIs, contribute to open source, it makes us feel good. And that's also great for the team. Test, 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 lots of tests. Yeah, best repeating. Write dev docs. It's so easy to just keep going and doing what you're doing. And then a new person joins the team, and what am I supposed to do? It takes weeks to onboard them in a complicated project. So, a beautiful data flow for a beautiful API sort of simplified how we actually did this decoupled API. We have our data sources, we put them in an import queue, we import them, always original data, and then we map it to a document store. The beautiful part about this is that between the document store and your API, there's not that much logic. So, in theory, you can also write your API on the edge. You can do absolutely anything you want with this kind of system, because you have the API very simplified. So all I really wanted to say with that is you can have messy data sources, but still a wonderful API. Thank you.